Hello everyone, welcome to My Dreams Academy, Dilshik Nagar, Hyderabad. Now in this video, we'll understand the reason for normalization, right? So now I'm taking a relational schema, roll number, name, marks, branch name, branch ID, branch HOD, branch contact. Now these are the instances, right? So 101, ABC and all, okay, right. Now why we are going for normalization, we'll understand. See here. So there is a student by name ABC with 10125 and he is associated with some branch civil and branch ID is 01 John 12345. Okay, fine. So see here, the problem is that this particular part, if you observe, right? So same information is getting repeated for all the students. Now this is what the repetition of data. Repetition of data. So in DBMS and especially in RDBMS, there is a terminology called for this repetition of data redundancy. Redundancy. So I have been introduced the terminology called redundancy. Now what is the problem with redundancy? Now we'll understand. So that there are three problems associated with redundancy. Now very first problem is, okay, insertion anomaly, right? First problem is insertion anomaly. Anomaly means it's a problem, right? How it is a problem? See here, if I want to insert, if I want to enter a student like 104, okay, I'll insert 104, okay, I'm inserting 104, his name is some PQR, he has got 24 marks. Now he's been admitted to which department? Obviously 104 means civil. So again I should write civil 01 John and 1 2 3 4 5. Right? So for one student, okay. Suppose if there are 100 students, thousands of students, what happens? I should repeat this particular information for every tuple, for every student. Now this is a problem. Yes, obviously it is a problem. So that's why that particular problem is called as insertion anomaly. Now why we got that particular problem? Due to redundancy, right? So that is what the insertion anomaly. Next one is modification anomaly. Modification anomaly. Now what is this modification anomaly? See here, suppose you assume that there are some 500 students in civil engineering department, okay, right? Suppose unfortunately HOD has got changed, or fortunately or unfortunately HOD name has got changed. Now what happens? I should update in each and every row. If I miss out for one particular student, what happens? Inconsistency created, right? So that is what the problem, right? So that is what the modification anomaly, right? I should update each and every student department information, right? So that is what the modification anomaly. Next, finally, deletion anomaly. Now what is this deletion anomaly? Deletion anomaly. See here, this 101 student has got transferred to some other college. Now what happens? I'll just remove him. I'll just remove him. Okay, now I'm just removing him. Okay, I'm just removing him. Right, 23. Now I should also delete this information. Yes, I'm just deleting. Now 102 also deleted. 102 also left the college. His information is getting deleted. So my intention is I'm deleting only student information. So if that student gets left college, now total information of that particular row will get deleted. Now my intention is only to delete the students. Okay, so I'm deleting. Whenever I'm deleting this particular row, total row will get deleted, right? So this also gets deleted. See here, my intention was to delete only the students, but unfortunately what happened, the total department information has also got deleted, right? If students left the college, means will the department will get deleted? No, right? But what happened here, as soon as all the students left the college, the department information also got the lost. Okay, so this is what the deletion anomaly, right? So how do we encounter this particular problem? So by using a normalization. So what we will do means, we will just split this particular table into two ideas. Now we need to understand the table. See here, this particular part indicates the student information. Now this particular part indicates the department information. Now both are two different ideas. So why are you clubbing two different ideas into the one table? So it's better to have a separate table for each idea. So student is one particular idea, one particular concept, and branch is another particular concept. So if you want to have a relationship between two tables, let us have a common attribute in between those two tables. So I'll do that now. So this roll number, this particular table has been divided into two. Okay, right? So this is the roll number, name, marks. Okay, I am divided. Next here also the total. Next, branch name, branch ID, branch HOD, branch contact. Okay, right? So this is what the splitting the two tables. But is there any common thing? No. So we should establish a common attribute between those two. So I am taking this branch ID here. Okay, I am just adding here branch ID. Okay, now in the earlier table there was 101, ABC 23, 102 DEF 24, 103 GHI 25, next 512 XYZ 24, next 434 ABC ABD or else XZP. XZP 23, right? Now 101, what is the branch ID? Obviously it is 01, this is 01, this is 01, this is 05, because CS is 05, EC is 04. Okay, now how many branches we have got? Only 3 branches. So instead of having total branch information for each and every student, we will be having just a branch information for all students. Branch name, civil, branch ID 0, 1, branch HOD like John 1, 2, 3, 4, 5. See here, now here two tables, here particular table has been split into two tables, right? So for 3 rows, for 3 particular rows, how many rows are there here? In branch information, only 1 row. Okay, so that is what the avoiding the redundancy, right? So now one more department is there. What is the department? CSC 0, 5. Okay, now what is this particular branch HOD name? SAM 54321. Okay, right? Now for ECE again, ECE 04 Jack 5 4 1 2 3. See here. So in this particular way we are going to avoid the redundancy, right? So why we are going for normalization means there is a repetition of data, right? So that repetition of data is called as redundancy. So if you have a redundancy in your table, then what happens? You will be having three problems: insertion, modification and deletion anomalies. So to avoid that particular anomalies, what we have done, we have just split the table into two tables having a one column as a common column between two tables, right? So in earlier case, for each student there is a one branch information, right? But here for all the students there is only one branch information, right? So for all the students there is only one branch information here. So like the way we are going to avoid the redundancy, right? This is what the reasons for normalization. In the next video we will see what is the definition of normalization and we will understand the steps in the normalization. Thank you.